Hi, good day, grade 11. In the next 2 weeks, as you accomplish all the readings and activities, you will be able to demonstrate understanding of the energy changes in chemical reactions. At the end of this learning module, you are expected to compute specific heat by experimental data, determine heat of reactions by calorimetry, and relate concepts of energy changes to practical applications. And at the end of this module, you are expected to search for an actual experiment design with computation of the use of calorimetric devices. Here are the reminders for you to be able to do your module assessment. So first, find the different calorimetric devices, choose one, and find an actual experiment where the device was used. Write or print the procedures done on the experiment. And then find a sample computation for the device chosen and copy the computation. Analyze the sample computation and write a 5 to 10 sentences explaining what you understand on the experiment and computation found. Again, present your output in an orderly and clean manner. Follow the experiment design of our previous modules. So it should have a problem, materials, procedures, and then methods and conclusion. And then include references or link for your final output. And of course, highest possible score will still be 30 points. Read and understand the rubrics to get the highest possible score. Activity 1 is a review of specific heat and heat capacity calculations. So again, I put a tip on how you will compute for each number. So for number 1, equate the two heat. So using the heat formula, equate each other, or you may refer to the readings below, which is heat of the system is equal to negative heat of the surroundings. Then, number 2, so since you don't know the sample here or the substance being studied, so your answer will be in reference to N is equal to Cp. So this will be your formula. The Q is equal to NCP delta T, and your answer will be based on number of moles. So reading 1 is about conservation of energy. So in conservation of energy, or the law of conservation of energy, states that heat of the system plus heat of the surroundings is equal to 0 to maximize the conservation of heat. It means that there is no energy wasted. Thus, heat lost by a system is gained by its surroundings and vice versa. So this is what I have stated earlier. Q system is equal to negative Q surroundings. And this is an experiment of how a specific heat is being determined. So in these readings, I have highlighted important notes or things that you need to remember. So for the experimental determination of specific heats, consider how the law of conservation is used in the experiment outlined above. This experiment, then read A to C. So in this, we assigned the heat of lead as the heat of the system, and heat of water is the heat of surroundings. So applying the equation Q system or heat of the system is equal to negative heat of the surroundings. We have heat of the lead is equal to negative heat of water. So, for example, we are asked to calculate the specific heat of lead. So, basing from this formula, heat is equal to mass times specific heat times delta T. Specific heat of water is already given. So, 4.18 joules per gram of water degree Celsius. So you can now compute for the heat of water. Using the formula, heat of lead is equal to negative heat of water. Therefore, heat of lead is equal to negative 1.4 times 10 raised to 3 joules. You can now use this value of heat to look for the specific heat of lead. And same goes with example number 2, but this time you are asked for the mass of the gold. Analyze, understand the problem, the example, for you to be able to answer activity 2. But I have put in number 1, I have put a tip on how you will compute for the required. So you can equate each other, the heat using heat of hot water is equal to heat of cold water. So it depends on which one you will assign as a system and as a surrounding. Again, please be consistent in choosing what is your system and what is your surrounding. And numbers 2 and 3 is the same as equating the system and the surrounding and finding the common unknown. So for readings 2, heats of reaction and calorimetry, we are still in heat, but this time by the use of devices. So a heat reaction is the quantity of heat exchange between a system and its surroundings when a chemical reaction occurs within the system at constant temperature. And then if a reaction occurs in an isolated system, that is one that exchanges no matter or energy with its surrounding. So the reaction produces a change in the thermal energy of the system. But the temperature is constant, or as stated here, either increases or decreases. Oh, sorry. So the temperature is not constant, but it's either increases or decreases. But in actual practice, we do not physically restore the system to its initial temperature. What we do is we calculate the quantity of heat that would be exchanged in this reaction. So we have two types of reaction, the exothermic reaction and the endothermic reaction. So exothermic reaction, temperature increase in an isolated system, or in a non-isolated system gives off heat to the surroundings, and it's it is a negative quantity. So the heat of reaction for an exothermic reaction is negative. And then for endothermic reaction, it is a temperature decrease in an isolated system, or a gain heat from the surroundings by a non-isolated system. Heat of reaction for this reaction is positive. As mentioned, we cannot just go to the initial temperature, but instead we calculate for the temperature or for the heat. We have a two-step process for the calorimetric measurement. So first is the calibration, in which a known amount of heat is generated in the apparatus. And the second step is the actual measurement. So this is our working formula for this reading. So heat is equal to C, which is the reading from the calorimeter times change in temperature. Change in temperature is still temperature of the final minus temperature of the initial. So as mentioned, this is an isolated system, therefore there is no mass or number of moles term where the here for the quantity of the material, since there is no exchange of mass. Once the calorimeter constant is known, we are ready to use the calorimeter for our actual measurement. So for step 1, so the pink highlight is the step 1. So we are to calibrate the calorimeter for us to know what is the value for the C. So we derive the C by dividing both sides by delta T. So we have a working formula of C is equal to heat divided by delta T. Substitute the values given, which is 100 joules of heat and increase of 0.85 degrees Celsius means there's a word increase. This is already a delta T, or a change in temperature. And then the pink highlights are the values you will be using for the actual measurement or the actual computation. So determination of heat evolved by the fuel. So you have your value of C times the change in temperature. So you have now a value of the heat of the calorimeter. So since your fuel is your system and the calorimeter is your surroundings, so the value of your fuel will be, the value of your calorimeter will be a negative value for the heat of the fuel. So calculate the energy density. So the energy density is described in the problem. So this part. Calculate the energy density of this fuel, which is the amount of energy liberated per gram of fuel burned. So energy density is the heat of the fuel divided by the mass given also in the problem, this 0.245 grams of particular fuel. You now have the value of your energy density. And then this discussion is just a analysis or a conclusion of the problem solving or a description of the problem, of the answer. And then activity 3 is somewhat a review, summary of what we are discussing in the past modules and in this module. So what is the difference between a system and a surrounding, heat and work, specific heat and heat capacity, so endothermic and exothermic. And then I gave a one problem for you to solve or for you to practice the computation part. And the tip is to follow the example from above reading to be able to answer this word problem. So from calibration to determination of heat and then to the energy density. And then for the activity 4, you apply your knowledge. So as mentioned, this is in your page 1, the let's prepare part. So find the devices that is used for the calorimeter or for the calibration of calorimetric value. But of course, if you have questions, inquiries, and clarification, please don't hesitate to message me. Thank you and good day.